I'm very excited to be at this conference because it's the first time that so many people from so many competing companies in this space are kind of in the same room, which is, it's been a very, very long time since that happened, and usually there were lots of lawyers present, let's put it this way. So I'm very happy about this. So you notice that even though I have the Microsoft.com name here, I didn't put the Microsoft logo on this because this really is a presentation about standards. I've been, as Charlotte said, representing Microsoft in Oasis, on AMQP, also a member of the MQTT, TC over there. I've been doing work in the IoT space in general with OPC UA, and I've been working on some CNCF projects. And so I want to go and especially present to you and give to your consideration a project that we've been working on with a few folks, including Doug Davis, who's also been in this standardization space for a long time. He's been with IBM for, I don't know, 24 years. Then came to Microsoft for a while, and I think he's now mostly baseball coach, but still working pretty hard on our project. And then Klaus Deissner, who I want to highlight from SAP, who's also been a partner in this effort. So where do we come from? So 7, 8 years ago, maybe, we got together on an initiative from Google initially to go and define what is an event, which seems like an easy question to answer, but it took us 3 years to kind of get to the point of defining what an event is. And we came out effectively with an answer that has 7 attributes. 7 attributes that define what an event is. And then having these attributes bound to protocols and to encodings. CloudEvents has meanwhile been fairly successful. It kind of finds its way into numerous CNCF projects. I see it in my daily work, customers coming to us and say, hey, we standardized on CloudEvents, and I say, good choice. So it's gaining foothold, and as it is with standards, right, it always takes years to kind of figure out whether something really sticks. But what CloudEvents is a great way to express an event on the wire and also go and document those events on the wire. What we also had as part of this effort is a schema registry. So we have a schema registry API that we put into the CloudEvents project initially, because we have an attribute in the Cloud Event called data schema. And data schema is supposed to point to a schema, but you need to have a place to put that. So there's a schema registry. And we also didn't like the fact that all the schema registries that were out there kind of had some weird license encumbered ways of not being free. So we said, let's go and make a spec. And then put that spec out there, and the CloudEvents project was a good place to put this. So then we had a problem as people who are building product. So we have been implementing CloudEvents in EventGrid. EventGrid is one of the eventing services that we have as a push service originally that has been kind of focused on CloudEvents. And when you have like Azure Blob Store raise events, then this is kind of how this came out. Like there's a documentation page, here are the events, and these are the event types, and here's some examples, how you do this in Cloud Event Schema. But you basically have to go by example. And so we didn't have a machine readable, so we have now a nice spec for how to go and express events, but we didn't have a metadata story around it. So we're like, how can we go and build a metadata story around it? So it'd be nice if we had something like, where's my thing? Here's my thing. Where we had a way to go and define events where we have, these are the Fabricam smart light bulb events, and then I have a few messages, and then I have the turned on event, and the turned on event is a CloudEvents event, and it has an ID and has a type. Here it says what that means. It has a source, where's that being raised from. It's required for it to have a time, and then the data content type that's being carried is an application JSON, even though the schema is actually Avro, and then having the schema actually sitting alongside of it. So having a registry that is kind of a versioned registry for payloads, but also is a registry that contains constraints for either filters or templates for events. So we can have a metadata foundation from which we can go and generate the documentation, but then also go and generate more interesting things like clients or kind of drive tooling. That'd be nice if we had that. So that was the initial motivation for embarking on the project that is xRegistry. Meanwhile, this is a CNCF sandbox project. The CNCF has kind of levels in which of maturity of projects. Sandbox is the level where you start having stickers. Which means that sandbox is the level where the technical oversight committee in the CNCF has first looked at it and said, this is not garbage. And then the next level is then kind of the next maturity levels are then kind of counting on adoption. When we built, so we set out and wanted to say we want to have a registry that covers, as you just saw, message definitions or event definitions and schemas, and then also endpoints, which you're also going to see in a moment. And then we set up creating 3 specs for those things after we had realized that putting it all into one spec would be too large of a document. And then we found that we had a lot of repetitive patterns across those. And then we decided, no, we're going to factor those things out into a common registry spec and then create a way we can go and create these specialized specifications as extensions. So came about xRegistry, which is the extensible registry, because we can now go and take basically any metadata model and plug it and create a universal metadata graph, which I'm also going to talk about in a little while. So it's model-driven. You declare effectively to the system, to an implementation, what is the kind of metadata you want to go and manage, and then the implementation can go and create that for you. What we also wanted to do is we wanted to create a symmetry between a REST API and a document format. Because when you go and create a module and your module raises 4 events, you have to go and put those declarations somewhere, right? You need to check them in with your code. And then from there, you need to be able to go and publish them. So what we decided is that a representation of a xRegistry inside of a file with all the various model instances is a legit registry. And all the tooling should be able to go and feed off that registry. And the API representation of that is basically X numbers of documents stacked on top of each other and served by an API server. And you get kind of a navigation model because loading it all into memory all at once is kind of hard. But we want to make sure that that this whole model works both as a document model and as an API model with implementation. And kind of the split in the middle is that you can go and take the metadata contents of an xRegistry, can shred it out into an S3 store or Azure Storage, and you can serve that as a static site. So you want to go and have full-on server, a static site server, and then single file that should all kind of work the same, so that this metadata story works at all scales. Because we are messaging people, we came out of the CloudEvents space. Our initial focus is on serialization validation schemas, message event definitions, and endpoints for asynchronous protocols, effectively, HTTP being by asterisk when it's used for that. So that was the goal. So I already said principal, documents, API, interchangeable. You can go and take the document and import into the registry API, and you can also go and export from the xRegistry API. Keep this all symmetric. Version management for resource types is completely built in. So for schemas, it's not meant to be Git. But the reason why we have version management in there is when you have a messaging system, you will have of a schema multiple versions in flight. And in flight also means there's there's events which are stored somewhere in storage, which you will go and rehydrate and run again. So those may be of version 1, and you're now at version 20. But if you are using a protocol, or sorry, an encoding like protobuf or like Avro, you have to have the original schema to even get at the data. So you need to have these versions of schema concurrently in a system available. So we needed to build a registry that can allow you to go and get at all those versions all at the same time. Because that's true for schema, we made this in a universal model, so you can have any resource you want in a versionable way. So the core specification set that you can go and find at our site, so this is kind of where this lives. So we're at github.com and then /xregistry/spec. This is kind of where our stuff lives. We have a primer. The primer is kind of an introduction and kind of gives rationale. You start to realize that I'm doing this talk just mostly to make you read a spec. Or a bunch of documents. The core defines the various entities and entity models that we have. So we have a concept of groups, we have a concept of resources, we have a concept of versions. And then we also have a concept of model and how the model kind of applies to those things. And we try to make these things, we try to make that spec very precise. It is so precise that if you load this into your favorite AI coding agent, they will immediately be smart and put good results out. I do this all the time. I basically just load up the specs kind of on the side in my instructions. And when I do work with this, it basically the coding agents know this. And so we're having there's a lot of AI kind of in mind here, even though we don't specifically write for it. Then we have an HTTP REST API, which then runs on the core. We've decided to split that off because we basically reserve the right to do an RPC API and maybe also kind of do an MQP API in the future. And then there's schemas that are built on top of the core. So we are generating JSON schema, Avro schema, and OpenAPI documents for the APIs. And then we have a set of events defined. So when the registry changes state, then we have a set of events that you can, as implementer, go and raise so that those are also standardized. And we have a pagination spec specifically for HTTP. Structurally, there's an entity, the API gives you effectively the notion of a group type. Then there's a group ID, there's a resource type, resource ID, versions, and then the version number. That's kind of generally the structure of it. That maps to the document format in the same way. So the document structure and the API resource path structure are the same, so that a relative HTTP path URI and an X pointer are exactly the same. And X pointer meaning JSON pointer in when you treat it as JSON. So that's the general model that we have in how we organize these things. So let's talk a bit about closer to all of our hearts. I had to go and tell you the abstract story. What are the specific things that we have? So we have a schema model, message registry model, endpoint registry model. The best explained this is by me showing you a few examples. You already saw one example here. So I have a message group, and the message group is called Fabricam Lumen. So we also have I can show you this also in the server. Now the IBM people are going to get a kick out of this. It's hosted currently as xregistry.soaphub.org. So Doug Davis is kind of hosting this. This soaphub.org. That soap is the soap you might be thinking of. It's that old. So it's kind of funny. So here we have a few endpoint definitions, message group definitions. Let's go into those. You see that there's some employee events group, and I can go and navigate into those, and you kind of get the message definitions. So this is kind of the API view, and Doug has made a UX, could use some help, but okay, that kind of layers on top of this. So here you have kind of these message definitions. And of course, I have the same thing here, kind of as same structure in this model. We have an envelope section, and we have then an envelope metadata section. We currently only define this CloudEvents envelope, but when you turn on the CloudEvents envelope, then you kind of light up this envelope metadata section. I'll show an extreme example, which is not CloudEvents, which is, I have this here, I think, yes. Here's Sparkplug-B. So Sparkplug-B is an IoT protocol which has several kind of roles. And so with this, we can go and define the protocol and then the protocol options. We can go and say, this is going to be on this particular topic because we allow for URI templates. There's a will message, which is defined kind of in the same set that this refers to, and a will topic where this is going to be sent to. You see that this endpoint is now referencing a message group, and these are the messages that are associated with the edge node. So these are all still endpoints, and now we get to the message group. So these are now the messages that are associated with the edge node, which is endBirth and endData and endDeath. And then you have the device messages. So you can go and do, this is the most formal declaration of Sparkplug-B that you have yet seen. We can do, here's a very simple example of an AMQP message, also not a cloud event, but we say the protocol is AMQP, protocol options, the subject field in the properties has this value. So when you, and then it is associated with the following schema URI, which is an XSD schema. So you can go and effectively always declare for Kafka, NATS, for MQTT 3.1.1, MQTT 5, for AMQP1, and for, what did I forget, HTTP. We have all the specific properties, all the fields that exist, and you can go and define them either as filters, right? You have a declaration like this, and you load this into a dispatcher. The dispatcher can now say, if a message arrives where the subject is my value, then it's obviously the contoso.my.group.my.event message, which means that even if no schema, basically if no schema reference is given, I know that I need to load the schema and apply it for validation. So it's a metadata, now you have a metadata story, and now you can go and format streams. Oops, hang on. Let me not destroy things on the way. So schema registry for any schema you like, right? Bring your own. We have predefined a few schemas, mostly just in the spec. We said, you know, JSON schema, the identifier marker needs to be like this, and Avro, and Proto, and XML. But if you want to bring ASN1 or whatever other schema you want, you can go and use that. For message registry model, as I said, we have these kind of as predefined protocols, and then one is the application neutral envelope CloudEvents 1. And then the endpoint registry model, similarly, the particular characteristics of AMQP endpoints and MQTT endpoints are all kind of predefined in there. So, and the point is that you can go and create a metadata information model, and you can go and store it in a well-organized way. And then you can go and share it out with others and also use consistent tooling. The schema model has, so this is kind of the models that you're creating. This is the model for the schema registry. There's a bunch of implied properties that are not in here, that don't need to be in here. But if you want to go and create a new subregistry, you basically create these model files, and then you define basically what is my singular name, the plural name is implied by the group's name, but you can also go and do this. There are compatibility statements. You can declare extensibility attributes or disallow them, and then you can go and create your own attributes and define them. And our reference implementation, the server, loads these models and then kind of enforces the contract that you're declaring here for these groups. To create these kind of multi-protocol scenarios, we have a very simple mechanism to go and create conditionals. So we have a thing called if values. So if you define in the model, you define, I have an attribute protocol, and in that protocol there's an if values, and if the value is AMP1, then take these sibling attributes and inject them at this level. So very simple. And what we didn't want to do is we didn't want to lean on something like JSON schema. Believe me, we tried. But we then ended up saying, no, we're going to go and do a super, super simple, very bespoke schema model here, because that's only here for our tooling, and we don't want to get in the hair of any of the other things. Let's go and do something that's very focused, and it's actually quite good. So with this, this is the spec set, and the spec set is, as said in that repo, there has been a lot of work done. There have been, the core group has been varying between 4, 6, 5, 7, sometimes people. We always bring the result of the work to the greater CloudEvents/serverless working group every Thursday at 6 p.m. European time in the morning at 9 a.m. on the Pacific coast. And there's several other people who are kind of interested in kind of driving this forward. So, and we've been also kind of building some tooling around this. The core tooling that's kind of in the core set, and that's actually the reference implementation, is the XR server. And that's the thing that I just showed you. Here, that is a containerizable Go-based implementation of the server. And then there's XR, which is a companion CLI tool of that server. Then there's a metadata-driven code generator and registry client, which is not quite there yet. That's going to be submitted very soon. But what that does is the following. So I can go and run based on one of those files that I showed you. So inkjet.xred.json, that's an inkjet definition. I can go and run this. So that's a code generator. Please, if you would. So Python is always fun. Sometimes it's fast, sometimes it's slow, and you can't really tell. Why? So let's go do this. So it now took one of those definitions and now turned this, yes, I trust the author, and emitted all the data objects that we need. And then it also emitted a Kafka producer from this, where the user, in the end, only sends, right, maybe one less. Where the user sends just the print job started event with the necessary extra parameters, but they no longer worry about creating the cloud event or interacting with packaging for Kafka. It just does that in the way how the template is already doing this. So there's a it's a template-based generator. There's Jinja templates that are in there. There's a bunch of extensions for code generation in that project. And so right now, so the core is kind of done, but now most of the work is basically stabilizing all these templates. And since there's a lot to do, that is kind of ongoing work. But the base infrastructure to go and take these definitions and then run them into the template generator, that's all there. And all of the ones that are currently, like this is what I just showed you, that's working flawlessly. And every project already includes the test projects that go with it. So here's a effectively built-in test that actually runs this against a test container. Then there's an xRegistry viewer, and the xRegistry viewer is an Angular app. And this Angular app can be pointed at endpoints. And so here's an endpoint that is a special xRegistry. And you'll see there's .NET registries and endpoint groups and node registries. And OK, well, so what's that? I'll get to that. Let me just show you. Let me just very quickly show you a video. This is from my talk that I did at the recent Fabric conference. So we now have a bunch of these definitions. We have message groups. We have schema groups. And we're applying them to in Fabric. We have a Microsoft Fabric is our data platform. We have a pipeline model, which is called event streams. So, and on the very left side, this custom endpoint source is really an event hub, Kafka. And so now I can go and associate one of those message groups with it. And through this whole pipeline, I now have type-safe messaging. And the effect of that is that if we go and take a look at this, so this is inside of the product. This is inside of Fabric. I have a so-called event schema set. And the event schema set, the nice thing about this now is not only that we have serialization metadata. What's really important for all of those fields is that they have a description, because we have an AI agent in the system. And to feed that AI agent with enough context, we need the descriptions. We need the schemas, not only to go and do serialization. We need it because we need the semantics. So you load those things into it, where, as you see, we're standardizing actually internally on Avro schema, because JSON schema is terrible. And so the effect of that, having these definitions, is that we can go and now, as I said, associate those in Fabric with these endpoints. And now I have this associated, all these definitions associated. And now I'm routing in what's called the event house. And the event house is our event database in the platform. I know. OK? And so event house. It shouldn't have stopped there. Anyway, so I'm going to tell you what happens. So in event house, because we have the metadata, we can actually go and generate automatically all the tables that are necessary with the right data structures. OK. So because it's extensible, we can also do a full metadata graph. That's actually what you're seeing here. So I have here other models loaded. And you see Python registries, Node registries. So this is the PyPy package registry as a pass-through. So there, we have a set of let me go and pick my advertise. So this is one of the packages from PyPy. We have models that kind of that make all the various package registries even as xRegistry representations. So we basically mapped PyPy, NPM, NuGet, OCI, and all those things to xRegistry models, and we have reverse proxies which do that translation live. So this is going towards a universal metadata tree. So if you want to go and have a universal view of all the metadata that's in your system, but you want to have it consistent, then xRegistry is a path towards that. So that's this. And status is we are at release candidate 2. We want to go and release version 1 before end of year. And call to action is please come and join us. Participate in the project. Get our code. File issues. I believe for the broker people, this should be something interesting, I think, because we're solving a problem in the open that everybody has. And I would be very pleased if we could go and build some greater community around this to kind of make type-safe messaging a thing. Thank you.